In this question, a convex lens is given. Refractive index of the convex lens is 1.5. Focal length of the lens is 80 centimeter when placed in a liquid. And the focal length is 20 centimeter when the lens is taken out of the liquid into air. We need to find the refractive index of the liquid. Since focal length and refractive index is given, there's only one formula relating focal length of a lens and its refractive index, that is lens maker's formula 1 by f equal to refractive index of the material of the lens divided by refractive index of the surrounding medium minus 1 by radius of curvature of surface 1 minus 1 by radius of curvature of surface 2. For a convex lens, you need to apply the sign convention. The R1 value is positive and R2 value is negative. If it's a concave lens, the R1 value will be negative and R2 will be positive. But here, convex lens, R1 is positive and R2 is negative. For getting that clear, if you're not okay with that, for a convex lens, we have two spheres. This common region is what acts like the lens, the blue colored region. The other part, just we show imaginary spheres. So this is the center of the surface one. When light comes from the left, this is the surface where light falls first. That's called surface 1. So its center will be center 1. After that, light comes out through the surface 2. Its center will be on the left side. So center 2. Now R1 you measure from lens to the center. This is the measurement R1. All measurement should be from the optical center towards the point. If the point is right, from optical center to the right will be positive. So R1 value will be positive. When you measure for radius of surface 2, it's measured from the optical center to the left. So that will be negative. That's why R1 is positive and R2 is negative. If you apply that, this equation will become 1 by R1 plus 1 by R2. So n lens by n medium minus 1 into 1 by R1 plus 1 by R2. It's a general formula. Now we have to come back to the question. First case, 80 centimeter when the lens is placed inside a liquid. So lens is given 1.5. Then focal length is given 80 centimeters. Medium is what they are asking the liquid. So for a lens once constructed, the radius of curvature remains the same. So this is the liquid instead of here F. So n lens by medium will be the now the liquid. 1 by R1 plus 1 by R2 because it's a convex lens. To substitute the value, liquid is given 80 centimeters. So n lens by n liquid minus 1 R1 plus R2 remains the same. So since it's not changing, even you keep the lens in air, water, anywhere, so we can change it as a K because we don't want to find it separate 1 by R1 plus 1 by R2. Just together take it as K. Now try the second case. When the lens is placed in air, lens medium is air minus 1 by R1 plus 1 by R2 can be K. Now focal length in air is given 20 centimeters. Lens is given 1.5. Air is 1 minus 1 into K. You can find the value as 1.5 minus 1 is 0.5 K. 1 by 20 is 0.5 is 1 by 2. So 2 and 20 cancel. You'll get the value of K as 1 by 2. Now that K value you can substitute here. 1 by 80 equal to n lens by n liquid minus 1 into K is 1 by 10. So 80 and 10 will go 8 will come. 1 by 8, take the 1 to the other side. 1 by 8 plus 1 is equal to n lens by n liquid. N lens is given 3 by 2. So 1 by 8 plus 1 is 8 plus 1, 9, 9 by 8. N lens is 3 by 2 and denominator n by n liquid. So 8 and 2 get cancelled 4, 9 and 3 get cancelled 3. So if we cross multiply, n liquid will be equal